Hello students, so we're back with a few more questions. Let's start. If normals are 2 points of a parabola, y square is equal to 4ax, intersect on the curve, then the product of ordinates. Ordinates simply means the product of their y coordinates. Okay. So let's say here I have 1 point and here I drew one normal. This point is, let's say, at1 square comma 281. You should also make this habit whenever questions are regarding normal, tangent, focal chord. Parametric form is most helpful when it comes to conics. Okay, let's say another normal is drawn at this point. This is q, this is q. Let's say at point q another normal is drawn, a t2 square comma 2a t2. So here, so both of these normals are intersecting on the parabola again, let's say at some third point, whatever that point may be. So we have to find the product of y coordinates, means we have to find the value of 4a square t1 t2, because that's what you will get when you multiply their y coordinates. So this is the entire scenario. Once you understand what is asked in the question, only then you can start thinking on how to process about it. So one line of thinking, there are two hints in this question only. Normals normals at 2 points, intersect and on the curve. So from this much only you can take your hint. First hint is intersection of normals. And again, if you remember the results that we talked about, so intersection of normals is 2 times a plus a into t1 square plus t2 square plus t1 into t2. This is the x coordinate, and the y coordinate is minus a t1 t2 into t1 plus t2. Okay, so this is the y coordinate. So it seems pretty difficult if you just go by this hint only, but we have one more thing, ki intersect on the curve. So the normals are not just intersecting with themselves, normal is intersecting with the parabola as well. And we know, if this is first result, and second result is, if normal at t intersects parabola again at t dash, then t dash will be equal to minus t minus 2 by t. You might be thinking that again, even if we get t dash, it is 280 square, 80 square comma 280. So how is that going to help? In that case, you can always go by the easier coordinate, y coordinate. Comparing the y coordinate will be easier. So now normal at t1, normal at t1 intersects the parabola again at minus t1 minus 2 by t1. So this is the parameter of that point, and we know the y coordinate. So y coordinate of that point will be 2a, this parameter, minus t1, 2a into minus t1 minus 2 by t1. And luckily we can compare the y coordinate of the point of intersection of normals because it is same. So you have minus a t1 into t2 into t1 plus t2. Now please, I'm going back to this idea again. Here, as you can see, this is the y coordinate of point of intersection of normals. Okay. So this right hand side of the calculation is from the point of view of point of intersection of two normals. Okay. But the left hand side is from the point of view of point of intersection of normal with the curve again. Okay. So that there is no confusion. Now I hope you can see there is some mathematical manipulation. We can cancel this a from both sides and we can take a minus common and cancel that as well. So we will be getting 2 into t1 square plus 2 is equal to this t1 will go there, t1 square t2. So t1 square t2 into t1 plus t2. Those who are wondering how come we got a t1 square there, there is LCM. Okay. If you take LCM, it will be t1 square plus t2, and this denominator has sent to the other side to be multiplied. And similarly, by symmetry, we can say the other result will be 2 times t2 square plus 2 is equal to t2 square t1 into t1 plus t2. Okay. Now you can just simply subtract these two results. Okay. Let's say this is result number 1. This is result number 2. So we can do first minus second. Now I hope you can see 2 common. It will be t1 square plus 2 minus t2 square minus 2. So 2 will be cancelled out. T1 square minus t2 square will be one result is equal to, I hope you can see on the right hand side, t1 plus t2 is common. And if you see, we can even take t1, t2 common. And also this will be t1 minus t2. Okay. So now I hope you can appreciate the fact that t1 plus t2 into t1 minus t2 will directly give you the 2 times t1 square minus t2 square is equal to t1 square minus t2 square into t1 into t2. So t1 square minus t2 square cancel from both sides. From here you'll get the product t1 into t2 is equal to 2. How is that going to help you? That is going to give us the answer. Why? Because they are asking product of ordinate. So product of ordinate is simply product of y coordinates. So 2a t1 into 2a t2. So if I multiply these two, I will be getting 4a square t1 into t2. And as we know, the value of this t1 into t2 is 2. So it will be 8 times a square. So which